Basically, we will work on power-based problems today. So let us take the first question. The first question, particle of mass m is moving in a circular path of radius r such that its centripetal acceleration varies according to the relation AC is equal to k square r t square. This is how it varies. Right. Okay, fine. I can see ECL students also. Someone I can see all the students, and not only that, even your voice can be reached to me. First కూర్చున్న పిల్లడు ఒకసారి రెస్పాండ్ అవ్వండి ఎస్ ఆర్ నో అని. మీరు మ్యూట్ పెట్టుకోనక్కల్లా.
Yes, sir.
Thank you. Good. Now this is how we'll run the show. AC is equal to k square r t square. What is centripetal acceleration? Centripetal acceleration is nothing but v square by r, which is k square r t square, which means v is nothing but krt. Right. Remember, in this circular motion, you need to notice that the speed also increases with the time, which means this is how velocity is, and this is how acceleration, tangential acceleration is. Lot of people fall for zero. When is zero correct? If speed is not changing, zero is correct, but speed is changing here. So therefore, what is power in this case? Power is nothing but tangential force times P. So how do I know tangential force? Simply, what causes the change in magnitude of the speed is the tangential acceleration. So what is tangential force? M AT into V. M AT K into R. V K into R into T. So finally, this is M times K square. M times, you can notice that. M times K square R square T. So option 2 is absolutely correct. Right. Yes. Any doubts? ECL? Any doubts? Someone say no doubt.
No, sir.
Right. Anika and team. Right. Thank you. Let us move on to the next question. We have a situation. Constant power is applied to a particle of mass m. Distance traveled by the particle when its velocity increases from v1 to v2 is. What is the definition of power? F into v. You said power is a constant here. Constant power P is applied. So P is mv. You can write acceleration in two ways, either dv by dt or vdv by ds, depending upon the given situation. So mv square dv is nothing but pds. Now do integration on both the sides. Now you have traveled some s distance. By the time the velocity is from v1 to v2. And by the way, this results in m times m by 3 times v2 cube minus v1 cube, and integration is ps. Therefore, s is m by 3p times v2 cube minus v1 cube. Any doubts on this? ECL?
No, sir.
Right. Anika and team? Right. Now we will gradually increase the level of difficulty, gradually. Right. Now here you have this question. Now this is not a constant power case. The instantaneous power delivered by engine of a car of mass 18 kg moving on positive x-axis is given by P is equal to 2x plus 5 watt, where x is in meter and which is nothing but the instantaneous position of the car. And it is starting from rest. You give me whatever the situation, I know only one thing, F into V. P is mv dv by dx times v. So therefore, now use the relations properly. 2x plus 5 is into dx is mv square dv. X is equal to 0 to some x. Otherwise, you said that x is equal to 0 starts from rest. So v. So this results in x square because integration of this plus 5x is m by 3 times v cube. That is the relation. That is the relation. And one more important point is you can answer C with this data. How? Now put x is equal to 1 in this. 1 plus 5 is equal to 18 by 3 times v cube. 3 6 times. And 6 and 6 cancels. Implies v is equal to 1 meter per second. At least one option you can use in this. Now, one more important point is, as you can understand from this situation, is the power increasing with the time or power decreasing with the time? How to know? Very clear from this, as x increases, as it moves, v increases. Speed is increasing. So if v is increasing, power has to increase. So therefore, A is correct. Here D is wrong because C is correct. B is wrong because A is correct. This is one way of doing this question. Otherwise also, KE keeps increasing. So power should be positive here. Right. Any doubt on this? Ask me right now. ECL students?
Yes, sir.
Any doubt? ECL?
No, sir.
Thank you. Right. Anika and team. Right. First, we will do easy questions. Then we will go for difficult ones. Now you see, power supplied to a particle of mass 2 kg varies with time as P is equal to 3t square by 2 watt, where T is in seconds. If velocity of the particle at T is equal to 0 is V is equal to 0, the velocity of the particle at T is equal to 2 seconds will be right. Hold on. Arya, you give me whatever the condition. My point is very clear. Power always for me is F into V, and that is a 3t square by 2. When T is given here, you should use in the place of F m dV by dt times V is 3t square by 2. mv dV is 3 by 2 t square dt m by 2 v square, because integration, you said that t is equal to 0, v is equal to 0. This will become 1 by 2 t cube. This is the integration which I have done. So with this, I can confidently say that at v is under root t cube by m. So under root t cube 2 into 2 by mass 2. Cancel. So answer is 2 meter per second. So you will get questions like this from power basic modes. ECL students, any doubt?
No, sir.
Akka? రైట్. అరే మా ఫ్రెండ్ ఉంటాడు లాస్ట్ లో ఈసీఎల్, వాడితో ఒకసారి మాట్లాడేసాం. ఫాలో అయినవరా? రైట్, థ్యాంక్ యూ. నెక్స్ట్ వరుణ్, ఫాలో అయినట్టేనా? రైట్. నెక్స్ట్, నౌ I'll take up difficult models. These are the difficult models actually. One after the other, I'll handle. Good questions. Actually, these are all really very good questions. Right. Now, first we'll take up a simple situation. We'll take up a simple situation, followed by we'll go for a difficult model. Right. Right. This question relates to old friction, work per energy and power. Right. Consider a long plank of mass 4 kg. See, when we face such question, don't be panic. Your aim should be very clear actually in such questions. You should be good at reading the question carefully. Remember, under these circumstances, the limiting value of the friction here is 0.2 into 2 into 10, which means 4 newtons. Whether they ask or not makes no difference. The limiting value of the frictions here is, both are limiting values only. 6.1 into 6 into 10. 6 Newton. Right. Keep that aside. On a long plank of mass 4 kg is kept a small block of mass 2 kg. Coefficient of friction between plank and ground is 0.1. And between plank and block is 0.2. You have a time varying force acting on the plank. Okay. At t is equal to 40 seconds is what you need to know. Now, first of all, forget about all these questions. This is our old question. Now, this is the block. Please try to understand the maximum. I think you try to please remember how I have taught you the maximum possible common acceleration is, what is the force on this? 4 newtons. What is the mass of this? 2 meter per second square. I am speaking about the upper 2 kg block. So the maximum common acceleration possible is 2 meter per second square. So as a whole, this system will have such an acceleration 2 meter per second square, assuming this is a 6 kg, and there is an opposition of 6 newtons, and you are applying a force of 0.60, which clearly implies 0.60 minus 6 is 6 into 2, means 0.60 minus 6 is 12. 0.60 is equal to 18. T is 180 by 6. Clearly, this is a 30 seconds. So I got one picture now. At 30 seconds, both will move after 30 seconds. Both will move with different accelerations. Till this point of time, I am teaching something long time back, what I have taught to you related to friction, right? And one more important point here is there is a opposition of 6 Newton. First of all, for 4 kg block to move, it has to overcome 6 Newton's force, which means, this is some in-between stage. This is some estimation of maximum common acceleration. Right. And by the way, initially also, your 4 kg block will experience, as a whole, the entire system will experience 6 Newton's force. Unless or until 0.60 greater than or equal to 6, means t is equal to 10 seconds, the system won't move. So I got a clear-cut picture about this system now. I am writing everything in detail right now. Right. So I have understood some points related to this. Now I will highlight that. Now, only then I will go for the next part of the question. From t is equal to 0 to t is equal to 10 seconds, all the blocks are at rest. This is the first statement. Now respond. ECL students, have you understood this statement? No. Think before that, because there is a lot of thing involved in this. From 0 to 10 seconds, both the blocks are at rest. Agreed? Yes or no? Because you know very clearly beneath 4 kg block, maximum opposition is 6 newtons. Unless or until your 0.60 equal to 6 newtons, means t is equal to 10 seconds, 4 kg block will not move at all. If 4 kg block is not moving, 2 kg block anyway will not move. So therefore, this is my first observation. Say yes or no for this.
Yes, sir.
Anika and team.
Yes, sir.
Right. Thank you. Next. Now, what is happening between t is equal to 10 seconds to t is equal to 30 seconds? What happens? Both will move together. Right. Now onwards, your problem take a different pace, which means now you represent as a whole one single system. This is all one single system, 8 kg block. This is experiencing a constant 6 newtons opposition, and this is experiencing 0.60 external force. Now you apply momentum impulse theorem. Now this is 0.60 minus 6 times 10 to 20 dt. This is force into time of the application. This implies change in momentum 8 into V minus 0, because initial momentum of the system is 0. This is a very hard core step. Confirm, have you understood this or not? I'm repeating again, this is a hard core step. Net force times dt is impulse. Impulse is change in momentum. This is what I've written. Confirm yes or no for this. ECL students first.
Sir, the system is 6 kg.
The system is?
kg.
No, it's 8 kg.
Yes.
Right. Thank you. Thank you. Right. Is this okay now? ECL.
Yes, sir.
Right. Anika and team?
Yes, sir.
Right. Now, this allows you to identify a T. No, I think I've done 30 seconds. I've written only 30 seconds. Now, what is happening? We will work out. We need to do the integration part. 0.6 by 2 times 30 square minus 10 square. Minus 6 times 30 minus 10 is equal to 6 times B. Right. There are 6 common multiplication, 0.1 right. Now we will work 300, 30 square means 900, 100, 800, 800 into 0.1, 80, 80 by 2, 40. Minus 30 minus 10, 20 is equal to B. Implies V is equal to 20 meter per second. There is no time to relax now. This is where I have started the problem now. Now I am going to give you what is happening over here. What is happening over here? I am going to give you the picture right now. Right. What is happening over here? I am giving you the picture. Right. Right. What is happening over here? Now I have understood one thing. Yet t is equal to t is equal to 30 seconds. అట్లా బాగానే ఉంది ఏం పర్లేదు ఏం కాదు ఎన్నింటి దాకా క్లాస్ 10:40కే నేను 10:20కి రిక్వెస్ట్ చేసేస్తాను ఇప్పుడు 10:20 వరకు క్లాస్ అయిపోతే చాలు అతనితో ఒకసారి బాలాజీతో మాట్లాడా అభిలాష్తో మాట్లాడా అభిలాష్ ఏమంటాడు ఆడు ఎగేసుకుని మరి నన్ను మెసేజ్ అడిగాడు అలా ఇప్పుడు అట్ట మాట్లాడతాడు అతనైతే బయలుదేరుతున్నాడు at t is equal to 30 seconds picture is ECL students are out 1 minute.
మీరు కాల్ చేస్తున్న వ్యక్తి
అరే మీరున్నారా ఏ ఎందుకు వీళ్ళు వెళ్ళిపోయారు ఎందుకు కరెంట్ పోయిందే మరి ఎలా సెట్ చేస్తుంది
వైఫై కనెక్ట్ అవ్వట్లేదు సార్ వచ్చింది సార్ కరెంట్
సెట్ చేసుకోండి రైట్ రైట్ చూడండి at t is equal to 30 seconds at t is equal to 30 seconds, the 2 kg is at that instant moving with the velocity of 20 meter per second. And now from hereafter, this will experience a constant frictional force. and that is fixed. What is that? That amount is 4 newtons. Now, and thereafter, the lower one I am speaking about, for Newton, this is a 6 Newton, 0.60. In fact, it is also experiencing 20 meter per second. Right. That is the picture at t is equal to 30 seconds. Remember, this is a constant force actually on 2 kg block. Okay. On 2 kg block, this is the picture. Now, what is happening to the lower block? Let us work. Now, on the lower block, you have 0.60 minus 10 times dt. On the lower block, 0.60. Right. Array, hold on. Array, I was just waiting for you. I didn't dot anything in between. ECL students respond? Right. Okay. Now, till here you are there. I didn't dot much in this. Now, at t is equal to 30 seconds, free body diagrams I have drawn. From hereafter, constant force on 2 kg block, but variable force on 4 kg block. Now, let us work on the lower kg block. On the lower kg block, from 30 seconds, they were asking about around 10 seconds. So therefore, that is around 40. This is equal to, at that instant 20, 4 times V minus 20. I've applied impulse momentum theorem. Force into time of action is change in momentum. Now, what is happening over here? 0.6 by 2 times 40 square minus 30 square minus 10 times 40 minus 30 is 4V minus 20. Now you need to solve this. You'll get some V value here. I'll identify that. Let me work on this. Now, this is 0.3. 1600 minus 900. That works 700. 700 into 0.3. 70 into 3. This is all 210 minus 100 is 4 times V minus 20. Implies V minus 20 is 210 minus 100, 110 by 4. Till here, any doubt? Please ask me right now. Anika. Right. Which implies V is equal to 20 plus 110 by 4. Right. Now, that is the instantaneous velocity of the lower block. I'll say VL refers to lower block. Right. What about the upper block? Upper block is very easy. Upper block is very easy. Why? Because it's a constant force. On the upper block, 4 newtons into interval is 10 seconds. And 2 into V upper minus 20. This is 40, make it 20. So V upper block is 40 meter per second. And V lower block is, this is 110/4. That can be written as 27.5 plus 20, 47.5 meter per second. Sir, why you are giving all these things? This is all what we have worked some 4 weeks back. Now you come to the question. Now in this question, the major problem is there is a relative motion and there is a loss also. See, there are losses happening 2 ways. One, across this border. 2, across this border. So therefore, power loss at the lower point as power loss at the contact point. This we need to work at the lower point at that instant. Right, this is 6 newtons minus 6 into 47.5 plus at the contact point, simply do one thing, relative. Relative means minus 4 into relative is 7.5. Now this is what you have. Now what is that you need to do is the calculation part. 6 times 47.5. Okay. This is a 285. And 4 times 7.5, 30. What is that they're asking? Heat produced at that instant. They are asking that heat is produced at that instant. So at that instant, heat produced is of this order. Whatever the power loss, that is the heat produced. I'll deal stepwise again. Just please follow me again. First, what is happening that we should have some estimation. Before I start this question, I told you very clearly, this is 0.2, mu is 0.2. Here the force of friction, you can see, is 0.2 into 2 into 10, 4 newtons. Maximum is 4 newtons here. Across here, maximum is 0.1 into 6 into 10, 6 Newton. First step is identification of this. Followed by our next stage problem is estimation of common acceleration. So what is estimation of common acceleration? The estimation of common acceleration involves 2 things. The first thing, estimation, is what is happening over here that one should consider. What is happening over here? I have clearly worked out that what is happening to me is at t is equal to 10 seconds only motion is starting. At t is equal to 30 seconds, relative slipping is happening. Now what happens is that after 30 seconds, you need to find relative acceleration also. That is the relative acceleration after that. So therefore, the total power you need to estimate. The total power you need to estimate. 1 minute. One minute, I just have some small disturbance. Right. Now, till this point, I have estimated that till 10 seconds, there is no motion at all. Okay, that's what the points that I have written. That's the points which I have written here. First point, t is equal to 0 to t is equal to 10, nothing is happening. T is equal to 10 seconds to 30 seconds, they will move together, right? So I felt some students here finding bit difficult in handling this. So now I have realized I want to do this question in a less amount of steps. This is the detailed analysis actually. Now I'll reduce the level of difficulty here. One minute here. Because you are finding all this is a nonsense process. So I'll delete this and I will solve it in a much easier method now. Much easier method. I'll solve this in a much easier method. Because you agreed to me till 30 seconds, there is a common acceleration. Now, what is happening after 30? Now, I just want to reduce this level of difficulty further. And if I am teaching that much number of steps, first level of students accepted this step. First level of students accepted this step. Even second level students accepted this, but they will not follow me throughout. Therefore, what I am going to do is, after 30 seconds, tell me what is the relative acceleration. I will approach in this way. Yes, easy method. Asalani steps with these. What is the relative acceleration? So what is the relative acceleration? How do I know what is relative acceleration here? Because at what do you call, what is this? Relative acceleration is what I need to find. So 30 seconds, where t is in seconds. Relative acceleration కావాలి నాకు. What is the above one? 2 kg block. Two kg block. And this is 4 kg block. So I will do the problem in the reference frame of 4 kg block, so that I'll get the relative acceleration on 2 kg block. Right. On 2 kg block, one force is 6 newtons. The other force is how much? 4 Newton. Point 60. We'll call this as A2. 4 Newton. We will call this as A1. So what is the relative acceleration? So now by the time 10 seconds arrives, now we will do it at a t is equal to 40 seconds. We want a situation. What is the relative acceleration? Here at 40 seconds, A2 is 0.6 into 40, 24. 0.6 into 40, 24. 0.6 434 minus 10 by mass 4. Similarly, what is the acceleration above A1? A1 is simply 4 by 2, 2 meter per second square. And this is 14 by 4, 14 by 4, 7 by 2 meter per second square. That's the acceleration of the lower block, and this is the acceleration of the upper block, right? Now, what is happening is, I want at t is equal to 30 seconds, at t is equal to 30 seconds, what is the picture? Now, as a whole, the entire system 6 kg will now have some common velocity because there is no relative slipping in between. We told that. So that velocity we will find right now. This is 6 newtons and applied force is 0.60. So 0.60 minus 6 is the net force dt. Do the integration is 6 times v minus 0. You will get some v. So at 30 seconds, what is happening? We will work. 0.60 t is equal to 0. Sorry, this will become 10 to 30. Right. Do the integration part. So you will get 0.3 times t square 900 minus 100 and then 0.6 minus 6 into 20 is a 6v. Right. Now, what is the loss? 900 minus 100, 800. 0.3 into 800 means 3 times 80, 240. Minus 120 is 6v. So v is 120 by 6, 20 meter per second. So at that point, velocity is 20 meter per second, right? 20 meter per second, what 30 seconds దగ్గర పవర్ లాస్ అడిగితే నేను ఏం చెప్పేవాడిని తెలుసా? At 30 seconds, as a whole system is moving with a velocity 20 meter per second and the only opposition is 6 newtons. So the heat generated is 6 into 20, 120 watt. ఇది చెప్పాల్సిన ఆన్సర్. Right. So that is how a difficult model is to be handled. So careful study. But నేనేమంటానంటే don't do these questions in exams. Why? You will anyway do mistake. But you should learn on now. అలానే ఇంకో మోడల్ ఉంది ఇక్కడ. ఇది చేయొచ్చు మీరు. We can do this. Try to do this question now. Everyone. A very large plank P of some unknown mass is being moved with velocity v naught I cap. Read the question. Everyone try to read the question. Is the screen visible?
Yes, sir.
A very large plank P of some unknown mass is being moved with velocity v naught I cap under application of an external force, which is not shown in the figure. Another block P of mass M placed on the plank is also moving with velocity v naught K cap. This is K cap direction, this is I cap direction, right? Coefficient of friction between the plank and the block is mu. Choose the correct options, right? Please try to understand, if I am in the reference frame attached to the frame of the plank, I will see that I'm seeing it from the top view. This is B. See, I will see that with respect to me, it has one velocity V naught in this direction, and it has another natural velocity V naught in this direction. This is with respect to observer attached to frame of Planck. Right. Therefore, what is the direction of relative velocity? This is the direction of relative velocity. Is friction opposing motion or relative motion? Anyone in the class? What friction opposes? Motion or relative motion? Therefore, this is the direction of friction. So, friction magnitude is mu mg. So, what is the direction of the friction here? Mu mg times a unit vector in this direction. On the table, please try to understand, downward direction is k cap, rightward direction is I cap. Now what you will represent, you know this one, I cap by root 2 minus k cap by root 2. That is the direction of the friction. Right. Agreed? Here, when I am seeing from the top, as shown, I am seeing from here. This is k cap direction, this is I cap direction, and this makes an angle 45. You know why? Because this is 45 degrees. So a unit vector in this direction will be I cap by root 2 minus k cap by root 2. That's what I have written here. Right. What is relative velocity? V relative. V relative is again V naught minus I cap plus k cap. That is the picture. So, kinetic friction, it's a wrong, right? What is the power developed by kinetic frictional force? Power is force dot velocity, dot product of these two. Mu mg v naught times I cap minus 1 by root 2 minus 1 by root 2. This can be written as minus root 2 times mu mg. Minus indicates loss. Just please confirm whether my step is right or not, please. And I have done one mistake here. One mistake. What is the unit of V naught? No, 1 minute. The mistake which I have done, I have identified. Actual velocity of the block is in the frame of, till here I am right. Till here I am right. Right. So, actual velocity is in this direction. Actual velocity is in this direction. So, F bar is correct only. Mu mg by root 2 times I cap minus k cap is correct. Velocity. This is with respect to observer. You want with respect to ground. Hello. With respect to ground you want. With respect to ground, what is the velocity? V naught k cap. V naught k cap. So now by careful observations, you will get minus mu mg v naught by root 2. Right. Right. That's the deal. Okay. This is option B. At T is equal to 0, heat dissipated per second in the sea. Are whatever B is your answer, that should be the case of D actually. So how come B and D be two different things? Got the point? So actually, at T is equal to 0, power developed with respect to ground frame by kinetic frictional force on the block B is, this is the correct answer. With respect to here, at T is equal to 0, when you said B is correct, D cannot be correct. Right. Now, please tell me, you have any doubt on this, ECL students? Right. Tarnaka students? Right. So mostly whatever that I have planned, I have done same model. Idi kuda ide model. But okay, but try that. This is the only last question for the day. PowerPoint of you. Okay. See this. Everyone try to solve this. Can you see the screen clearly?
Yes, sir.
Right. At least you try this, everyone in the class. Otherwise, I will do. Already I have discussed this model. One single formula, you can never do these questions. Please remember, I am discussing about purely IIT questions. Just one single formula will not make very big difference. Consider two blocks made of some material. The frictional force between the blocks opposes the relative motion of the blocks and has a magnitude, obviously some constant times the relative velocity, where u1 bar and u2 bar, the velocities k is something like this. Power delivered by the friction F to the upper block. Now, what is the relative velocity? With respect to the lower block, what is the relative velocity? Relative velocity is 10 minus 5 meter per second. So therefore, the friction part is K, 2 into 5, 10 Newton. Right. So therefore, we'll call this as A, this is B. On A, when you see relative velocity is 5 and the friction is 10. So therefore, power delivered by F onto the lower block is Simple. On the lower block, this force is opposite. F is equal to 10 newtons. That instant, its speed is 5 meters per second. So therefore, from this, I can say power is force into velocity 10 into 5, 50 watt. Don't question me why it is plus. Yes, it is doing positive work on P. Power delivered by friction on lower block is positive. Right. Right. Total power delivered by the friction F to the system of blocks is simple. Power is F V relative. Now, in this, F is minus 10, V relative is 5, so minus 50 watt. So it is minus 50 watt. So the total power delivered by the friction F to the block is minus 50 watts. Sorry, you are cheating. No, I am not cheating. Suppose if I am cheating, otherwise also I'll deal it in individual basis. Now you agreed that block A will experience at that instant 10 Newton force and it has 10 meter per second velocity. On B, నాన్న యాక్చువల్గా నేను ఇది చెప్పి ఇది వెళ్తే బాగుండేదేమ్మా ఓకే ఇగ్నోర్ దిస్ బట్ యు ప్లీజ్ వర్క్ ఆన్ దిస్ ఆన్ బి ఇట్ ఈస్ 10 Newton and it has 5 meter per second velocity. So what is the power here? P1 minus 10 into 10 minus 100 watt. What is the power delivered to here? Plus 10 into 5 plus 50 watt. What is the total power? It is minus 50 watt. ECL and ECL students, have you followed this?
Yes, sir.
ఇది ఈజీగా ఉందా ఇందాక ఈజీగా ఉందా
It is a yes, sir.
ఈ మోడల్ ప్రాక్టీస్ చేసుకోండి ఓకే
Yes, sir.
రైట్ రైట్ Tarnaka students,
Yes, sir.
right, followed. So I have done all power based questions here mostly. Nothing is left from my side. These are all pathfinder questions which I will deal it separately. ఇందులో కూడా ఇది చెప్పేశాను మీకు ఇది మీకు చెప్పేశాను నిన్ననే చెప్పేశాను రైట్ సో విత్ దిస్ మై ఎండ్ portion is done. So now what will happen is I'll try to provide you this week's question paper. You do practice. You do a rigorous practice on this. But meanwhile, I'll just need to discuss 1 minute. So some of the questions, previous IIT questions, we'll work on this. Right? Everyone try this. There is a previous, I think you can say 2018 question. Any doubts? A particle of mass m is initially at rest at the origin. It is subjected to a force and that starts moving along the x-axis. Kinetic energy, rate of change of kinetic energy is given to you. Gamma is positive. Which of the following statement is true? So dk is gamma t dt and do the integration and you'll get kinetic energy starting from rest. I think it's mentioned gamma t square, right? And that is one aspect, and this is also same as half mp square. So one thing is very clear from this, I can say v is proportional to t and acceleration is constant. So therefore, the force applied on the particle is constant and the speed of the particle is proportional to time. Since it is a constant force, if a force is constant, it is conserved. Force is conserved. Any doubts? ECL students.
No, sir.
Can I proceed for the next question?
Yes, sir.
ECL students.
Yes, sir.
Right. Pakka this week question. Student, a student gets up the ramp that makes an angle 30 degrees with the horizontal. He or she starts as shown. Okay. Reaches maximum height from the ground as shown in the figure. Assume that the energy loss is negligible and the force required for this turn at the highest point is provided by his or her weight only. Right. Now, what is that they are asking in this question is bottom of the ramp speed is V naught. Right. Can I ask a question? Easy staying at rest here or easy having some energy at that point? He is having velocity at that point. I repeat, is he having velocity at this point? Yes or no? He should have velocity. Otherwise, how circular path is possible? Tell me. So therefore, at these 2 points, apply law of conservation of energy. So half mv square plus mgh is the energy there, and half mv naught square is the energy at this point. Now you compare. So, and one more important point, at this point, circular path is enabled. This is a circular path at this point. So at this point, what supplies the necessary centripetal force? The component of the weight supplies the necessary centripetal force. In fact, G sine 30 and V, which clearly implies V square by R at that point is G sine 30, G by 2. So wherever I have V square, I can write RZ by 2. Right. Now I'll use this relation over here. Half m v square is Rg by 2. Rg by 2, v square is Rg by 2 plus mgh is half mv naught square. So v naught square minus 2gh is Rg by 2. So A option is correct. The centripetal force required is maximum at points x and y. How do I know? If this is v, at this point velocity is v1. Remember, as you go up, speed decreases. Here the speed is maximum when compared to that at y. So therefore, at v1, very clear, centripetal force required is maximum when compared to at y. Out of x, y, z, x and z are similar points. So therefore, we require maximum centripetal force at that point. Yeah, I know you have maths class. This is the last question from my side. Done. ECL students, మీరు prepare అవ్వండి. Right. Okay, just tell me